So we're finding the domain and the vertical asymptote. Asymptote is a line that your graph will get really close to but will never touch. So if you take a look at this graph is approaching, I'm going to make it a dotted line. Right here there's a vertical asymptote where your graph approaches but will never touch this line. So, and the equation for this line is a vertical line, so you know it's going to be x equals something, 0, -1, -2. So this line is a vertical asymptote where it's x equals -2. We will talk about the horizontal asymptote. That is also the line that approaches the graph but will never touch. But we're only talking about domain and vertical for now. So the vertical asymptote is x equals -2. But if you look from the graph, you can find this even if you don't have it graphed. So when you look at that, notice that x equals -2, x plus 2 right here in the denominator. If you were to solve it for x, so x plus 2 equals 0, minus 2 from both sides, that will give you your vertical asymptote from the denominator. So the domain of a rational function includes all real numbers. Notice that it's everything going all the way over to infinity on the negative side and approaching that asymptote. But it will be everything, and then it keeps going that way. So it is everything except the x values that make the denominator equal to 0. So, and that's exactly what we did here. So we got the denominator x plus 2, we set it equal to 0. So if my x is -2, if I plug that in for x, that will make my denominator equal to 0. And we already talked about how we cannot divide by 0. That's why my denominator cannot be 0. Or in this case, my denominator, my x, cannot be -2. And that's where the vertical asymptote comes in. So and what would make the denominator equal 0? So, and that's what we already did right there. So x plus 2, that makes it equal 0, minus 2 from both sides. So x equals -2. So your denominator, your x equals -2, that's what makes your denominator equal to 0. So x could be anything except -2. This is the same thing as the restrictions we've been doing when we're solving rational functions. So because -2 would make your denominator equal to 0, and you can divide by 0, that's why you have this vertical asymptote right there. There's the gap. So since we're talking about that, the vertical asymptote equals -2. That was the very first thing we did, right there. But look at this other graph. You can clearly see 2 vertical asymptotes on that one. And that is that right there. And that is that right there. And we know since it's a vertical line, it's going to be x equals 1, 2. So x equals -2 for that one. And x equals 1, 2, 3 for that one. X equals 3, x equals -2. So yes, you can have multiple asymptotes depending on the function or the degree of the function. So now they gave us just a function without the graph. We're going to have to figure that out. So we know we have to compare the denominator, and we know that that's when the denominator equal to 0. So factor that. This is clearly a difference of squares. So now I have the numerator. To find the vertical asymptote doesn't really matter. And we know to find the domain and the vertical asymptote, we have to find what makes the denominator equal to 0. So domain is everything except, it's all real numbers except those numbers that make the denominator equal 0. So positive and negative 2. And we know that the vertical asymptote is that vertical line that makes the denominator equal to 0. So they're closely related. The domain is the restriction, the vertical asymptote is the line. Factor that. Domain is what makes your denominator equal to 0. So that's your restriction. X cannot be 0 and x cannot be negative 3. Vertical asymptotes. Notice that we're going to have 2 in this case. So 2 vertical lines, one going through 0 and one going through negative 3. Last one, we're going to have to do some factoring right there. Now we can factor mentally. Divide by 2. Simplify the fraction. Again, the numerator is not important for us to find the vertical asymptote. Only we're going to talk about horizontal asymptote next. So x minus 3, 2x plus 1. Okay, so domain is the restriction, so x must be different than those numbers that will make your denominator equal to 0. So positive 3 and negative 1/2. If you don't know where I got this from, you have to set this equal to 0 and solve for x. Vertical asymptote. Those are the vertical lines that go through 3. And that goes through negative 1/2. That's it.